This week we'll be working on natural exponential and logarithm functions as a building onto what we were working on last week with logarithmic functions. So the natural exponential function, previously we've pretty much been doing everything in base 10. Now we're doing it in the base of e. We write these functions as e to the x, and e is this number 2.178. It's irrational. It's similar to pi. Goes on forever and ever. It's a hard explanation where it comes from without calculus. So you'll learn it someday if you take calculus. And then you should be able to find this e to the x in your calculator if you need it. Graphs of these look like an exponential function. Starts low and goes high. All you do is you plug these values in for x, and then you get out decimals, and then you plot those decimals. So there'll be a couple of graphing questions. The main thing is just plot the points and then connect them to make it look like an exponential function. We're going to start out by doing some factoring. There's two ways you can do these. One is you can kind of just look at and work through it. So here, each of these shares an EX. If you have a hard time seeing that, then let's do some substitution where we make Y is equal to E of X. So then this will become Y squared minus Y over Y. I now see they all share Y, so I can pull the Y out, or divide by Y, I mean, because this has a Y, this has a Y, this has a Y. So then we would have Y minus 1 over 1, which is equal to Y minus 1, which is equal to E to the X minus 1, because Y equals E to the X. All right, next, same idea. I'm going to change the E to the X out for Y. So now we've got 4y squared minus 3y over 2y. So here the y's can cancel because they all three terms share a y, but they all don't share a 2. Only these share a 2. And so because of that, we can't cancel the 2 out, only the y's, and we're left with a 4y minus 3 over 2. So we'll have some word problems that we're working through. It's going to give you the formula here, and you just got to know what you're trying to solve for. So on this one here, we've got n to the t, or n of t equals 1,000 e to the 0.1 t. So e is called the natural logarithm. I think I already said that. Maybe call it something different. But it shows up all over the place in real world scenarios. It's pretty incredible. So this is one where it shows up where this can show us how fast something's growing or decaying. So we want to solve for t, or we're going to plug 4 in for t here. So we've got n of 4, which means we're plugging 4 in for t. We got 1,000 e 0.1 times 4. You can use your calculator here. Oftentimes, I will just do times e and then raise it to the power myself. So here it's to the 0.4. And you should get n of 4 equals 1,491.8. But you can't really have 0.8 of a bacteria, so let's just round it up. Make it nice. Bacteria. Remember, it's a word problem, so you need to put your units there. So go ahead and take a minute to try these two. You can pause the video. For the second one, it says plug values in for t. We're going to show how to solve exactly for t in a later slide. Right now, you can just kind of do some guess and check. All right, so then your answers here will be 2,718 bacteria for the first one. You just plug 10 for t and then plug that into your calculator. And then the second one, if you plug in, it's basically 23, you could say, but I just want to give you the exact number so you kind of figure, I don't know how detailed you got in your guess and check, but 23 hours would be fine for that answer. So now we're looking at the natural log function, which is ln of x. So when you see ln, that's the same as log base e of x, but we give it its own special notation because it's used so often. It has the same properties as log, so here are all the properties. We've talked about most of these already. This might be one that we haven't talked about, so that's a good one to be aware of. Everything else I think we're talked about. So then we're going to be working through simplifying some of these. For this one, we can use our property where we can expand this out, where this is equal to ln of 2 plus ln of e. We know this is equal to 1. There is an ln button on your calculator. Natural log ln of 2 is 0.69 plus 1, so we get 1.69. Let's use our exponent property first. So this will become ln of 3 squared minus ln of 2 cubed. We can then write this as one big division problem, which would be ln of 9. 3 squared is 9. 2 cubed is 8. And then ln of 9/8 is 0.117. Using order of operations, we got to go left to right here. So we're going to start by combining these into an ln 5 times 3 minus ln of 15. So then we have ln of 15 over 15, which is equal to ln of 1, which whenever you do natural log or log of 1, that's equal to 0 every time. So this was the problem from your practice, or second practice problem from earlier slide. What we want to find is how long it will take to reach 10,000 hours. All we're going to do here is we're going to take the natural log of both sides. Well, actually, before we even do that, let's divide by 1,000. So then we have e to 0.1t equals 10. Now we take the natural log of both sides because the natural log of e is 1. So then we're left with 0.1t equals natural log of 10. Divide both sides by 1/10, and we get t equals natural log of 10 divided by 1/10. And that's where you get your answer of 23.0203. And it's asking for time, right? So that'd be 23. What was the hours? What was the time length? All right, so then the last couple of problems we'll have are solving ones that look like this. There's a couple different ways you can look at these problems. This one, we're just going to do the natural log. You could also do the log of both sides, but since we're in natural log chapter, we're doing the natural log. So we get x squared times ln of 4 equals ln of 9. Divide both sides by that natural log of 4 to get x by itself. So we get x squared equals natural log of 9 divided by natural log of 4. And then take the square root of both sides, and we get x equals the square root of natural log of 9 over the natural log of 4. which should get you an answer roughly at 1.26. Last one here. Again, we could do log. We're in the natural log chapter, so here we are. So then we have x plus 2 in parentheses, because that's a whole quantity, times the natural log of 4 equals 2x minus 1, natural log of 7. We want to get these x's by itself, so we're going to distribute out. We're going to have x natural log of 4 plus 2 natural log of 4 equals 2x natural log of 7 minus natural log of 7. I'm going to subtract this 2 ln of 4 from both sides. And I'm going to subtract this 2x ln of 7 from both sides. That way I can get my x's on the same side and then distribute or factor. So x natural log of 4 minus 2x natural log of 7 equals negative or natural log of 7 minus 2 natural log of 4. Factor out the x over here. Don't lose track of your L's and your 1's. I almost did right there. And then you're going to divide everything by this natural log of 4 minus 22 natural log 7. See, almost did it again. And then we've got natural log of 4 minus 2 natural log of 7. So x equals whatever this comes out to be, which when you type that into your calculator, you should get 1.88. One thing to know is if you have something like 4x plus 2 equals, 16, 2x minus 1, you can do all that work we just did. There's also a clever way where we can rewrite 16 as a power of 4. So then that becomes 4x plus 2 equals 4 to the 4x minus 2. And because the bases are the same, these exponents have to be the same. So you can just set it as x plus 2 equals 4x minus 2, then solve for x. But that's only when you've got numbers that can be written as the same powers of each other.